Factoring Special Cases, Part 2, Difference of Squares. All right, when you have this situation, when you have a perfect square and a perfect square but no middle term, it factors like this. The square root of 9 is 3. Remember, this is a 1 in front of that, which is a perfect square. So in this case, it'll be x and x, 3 and negative 3. You need the one positive and one negative so that when you multiply these two, you get the negative 9. This one, the square root of 100 is 10. So we have a positive 10 and a negative 10. X plus 10, x minus 10. Oh, the reason there's no middle term, when you do the outside-inside, you get negative 3x plus 3x is 0x. There's no middle term. Negative 10x plus 10x is 0x, no middle term. We say the outside-inside cancels out. Now we have a number in the A position that's not a 1. So here's a perfect square. Don't forget, 1 is a perfect square. So we do the square root of 4x squared. That is 2x and 2x. The square root of 1 is 1 and 1. We need a positive 1 and a negative 1. 2x plus 1, 2x minus 1. When we do the outside-inside, we get negative 2x plus 2x cancels out. Now notice, I'm not writing these answers as parentheses squared like over here because this is the same sign, plus and plus, so we can write that as x plus 2 parentheses squared, x minus 3 parentheses squared. Whereas over here, it's a plus and a minus. It's not the same thing. So the answer has to be written with two sets of binomials. Here's another one, perfect square, perfect square. Square root of 25 is 5, 5x and 5x. Square root of 36 is 6, 6 and 6, 1 plus, 1 minus. When you do outside-inside, you get negative 30x plus 30x. Remember, I showed you this in notes one day in class. When there's no middle term, there really is a middle term. It's just a 0x. It's there, it's just hiding. You don't need to see it. And if there was a 0 term there, we could do the x method here. A times c, negative 900. The middle term is 0. The two side numbers that multiply to negative 900 and add to 0 are positive 30 and negative 30. Divide by the a number, 25x, 25x. That reduces to 6 over 5x, negative 6 over 5. The x is attached. Positive 6 over 5. The x is attached just to remind you that that's how it goes in the parentheses. 5x plus 6, 5x minus 6. The idea with special cases again is you don't need to do this down here. If you know the pattern, it is very simple to factor. All right, now the general formula looks like this. And we're almost done here. But in general, if a and c are perfect squares and there is no middle term, bx, and there is a subtraction sign, then you have difference of squares. Remember, difference means minus, means subtract. That's why it's called difference of squares. Example, perfect square, minus sign. Square root of 36 is 6, square root of 1 is 1. 6x plus 1, 6x minus 1. 6x plus 1, 6x minus 1. Perfect square, minus sign. X plus 2, x minus 2. Perfect square, plus sign. Uh-oh, wait a minute. All the other ones had minus signs. Is there a sum of squares? Question mark. Sum means addition. No, there's not. There is, or are, no two binomials that multiply to give you a sum of squares. If you write x plus 2, it will produce a middle term. A middle term will be the bx number. If you write x minus 2, it will still produce a middle term. It will produce negative 4x in the middle. This produces 4x in the middle. These don't work. And you can't have a plus and a plus 2 minus 2, because it won't multiply to positive 4. So there is no sum of squares. No. Let's see. Perfect square, minus sign, 3x plus 6, 3x minus 6. 3x plus 6, whoops. 3x minus 6. Oh, wait a minute. I wanted to show you this because sometimes things can factor twice, or we can factor out before we start. Did you already catch that? That would be good if you did. If you didn't, that's fine. Look at this. I have a 3 and a 6. I can still factor out a 3. Factor out a 3. That 3 comes out. I'm left with x minus 2. Plus 2. Here I have a 3 and a 6. I can still factor out a 3. X minus 2. Now, in multiplication, you can multiply in any order. It doesn't matter. This is just 3 times 3. That's 9. 9 times x plus 2, x minus 2. Well, look at this. What if I started this one by factoring out a 9? 9 times x squared minus 6. Minus 4. Yeah, 9 times 4 is 36. Minus 4. All right, are you with me? I factored out a 9 to start, so I have this. And then the 9 just stays out here, and there's my difference of squares. X plus 2, x minus 2. All right, so it's always helpful to factor a number out before you start, but if you don't, and you wound up with this, you would have to notice that, oh, wait a minute, these, I still have a common factor I can take out. Okay, and the general formula. If you have a number that can be written as a square, and a number that can be written as a square, and a minus sign, here's your general formula. Example, if you have 25x squared, 25 can be written as 5 squared. That's like that a squared. 4 can be written as 2 squared. So whatever that number is, the square root of 25 is 5, it goes here. Whatever the square root of 4 is, that 2, it goes here. 5x plus 2, 5x minus 2. And that's it. Now, practice on the CUDA worksheet. And the idea being, you don't have to set up the big X. You don't have to do any other methods you've learned. You can just use the patterns to go right to the answer. It should be very quick once you get the hang of it. Take care. Bye-bye.